let's read the problem first, okay? Bryce, go ahead.
Number
40
40.
to 43. Let's read the instruction first. Thank you.
For the following exercises, follow all the complex solutions.
Thank you, right? So we need to find the real and the imaginary solutions for such. Ready? Okay. So, and Bryce, you said what number? Huh? 40, 43, 40?
Yeah.
40? Okay, let's see in here. Number 40. So we have the following. X cubed plus x squared plus x plus 1 is equal to 0. Are we good? Right? Okay. First of all, let's consider the Descartes rule of signs, right? So for your f of x, so how many positive roots are there? Maximum positive roots. 0. Very good, right? We good? Right? Positive, 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 positive. There's no sign change, right? So that means 0 positive. Are we good? Maximum, okay? Next, how many maximum negative roots are there? So once again, what we're gonna do, make them all negative x's instead, okay? So let's do that one, right? So make this one. F of negative x is equal to what? Negative x cubed plus negative x squared plus negative x plus 1. Get it? You good, right? So again, we're just evaluating all of those at negative x's, right? Okay. Now, if it's odd, sign change, right? Get the negative. Good. If it's even, disregard the negative, right? So still positive. We good? Okay. Now in here, this is negative x plus 1. Are we good, guys? With our negative numbers raised to a power, right? If it's odd, make it negative, right? If it's even, just copy the sign. Get it? Now with that being said, now how many sign changes are there? Are here? From negative to positive, how many? 1, right? So 1 sign change. From positive to another negative, another sign change, right? From negative to another positive, another 1 sign change, right? So how many maximum negative roots are we expecting? 3. Maximum, right? That's maximum, right? But it can be less, right? By what? By pairs. So after 3, what's the lesser value? 1. Are we good? Get it? Okay. So it cannot be 2, right? Because again, compensating for the imaginary roots, that means always 2, right? Okay. Next, how many imaginary roots are possible in here? Possible imaginary roots, how many? Possible, okay? Not the actual, right? Possible imaginary roots. Answer, maximum is 2, right? Well, there can be no imaginary root as well, right? But the question is, can there be 4 imaginary roots? No, right? Madeline, why?
Because it's degree.
Very good, right? Definitely, your number of roots cannot be more than the degree. Are we good? Get it? Okay. Well, anyways, let us graph it to confirm our answer for such, right? Let's graph it really quick and see how it looks like, right? X cubed, there we go, plus, what's this? X squared, plus x plus 1, right? So confirming our answer, we good? Right? Confirming our answer, what is that? 1 is one of the roots. Negative 1. Get it, right? So in short, the answer is what? We have 1 negative root, right? We have no positive root, right? But since there are that's degree 3, Then how many imaginary roots do we have, actually? You already have one negative. You have no positive, but there are degree 3, right? So how many imaginary roots do you have, actually? Candy? 2. Very good, right? Because 2 plus 1 plus 0 is equal to 3. Are we good? Get it, guys? Well, again, it says in there, find the actual roots, right? We're gonna do this one by synthetic division really quick, alright? So what's that gonna be? X cubed plus x squared plus x plus 1. Again, we're using synthetic division. Get the coefficients. What's that? 1, 1, 1, and 1. Get it? Okay. On our divisor box, we're gonna put in here what? One of the factors. And what is that factor? X equals negative 1, right? Or actually, it's the 0 already, right? Okay, good. Well, let's figure it out, right? Let's get the quotient. Ready? Okay, what we're gonna do? What we're gonna do first in here, guys. First term,
Down the 1.
bring down, all right? Okay. What do you do with this and this? Multiply and add to the next column, right? So this is negative 1. Okay. Oh, what's the result of that one? Adam, 1 plus negative 1? 0. Very good. And let's continue, right? 0 times negative 1. What's that gonna be? Victor? 0. Put it in here. Okay, let's add them together in here. Absalom, what's that? 1 plus 0. Very good. 1. Okay, what's next in here? Hobbs, Christian.
Negative 1.
Negative 1. Very good, right? And the last one in here, what's that gonna be? Olivia? 0. So 0 is the remainder. Now what's your quotient in here? What's the quotient in here? What is this? Very good, right? 1 degree less than the original function, right? So this is what? X squared plus 1, right? This is what I'm gonna do. I'm gonna set it to 0, alright? And again, in here, to compute for the 2 imaginary roots, right? I can, what? Use either quadratic formula or use our factoring technique. We get? So what we're gonna do in here? I would say quadratic, just solving for x would be fine, right? What do we do? Minus 1 both sides, right? Okay. This will cancel out. Hence, x squared equals negative 1. Get it? Okay, okay, what's next for this? Square root both sides, right? So square root both sides in here. We go. Cancel the square and the square root because they're inverses of each other. Hence, x is equal to what? Plus or minus? Again, when you say square root of negative 1, by definition, what is that? I. Very good, right? So recall our 3.1. If you see square root of negative 1, by definition, I is equal to square root of negative 1, right? And again, you can also use quadratic formula for such if you want to, okay? Get it? With the A, B's, and C's. So, what are all the roots? So what are all the roots in here? All the actual roots. What did you get? Negative 1, I, and negative I. Okay. As you may notice, these two are what? Conjugates of each other. Get it, guys?